We now determine the exact value of tangent of 67.5 degrees, and we are going to find this using the half angle identity for tangent. So here we have the half angle identity for tangent, that is tangent of x over 2, and this equals we have three expressions. The first one is plus or minus square root of 1 minus cosine x divided by 1 plus cosine x, and the next one, and this equals sine x over 1 plus cosine x, and this also equals 1 minus cosine x over sine x. So for this problem we will be using this form. In fact, you could use any of the other two forms as well. So let's use the second one. And since we are going to use the half angle for tangent, we have to consider this part as x by 2. That is x by 2 equals 67.5 degrees. And this implies we multiply both sides by 2. X equals 2 times of 67.5 degree, and this equals 135 degrees. So we have determined that x equals 135 degree. So we write this as tangent of x is 135 degree divided by 2. In fact, when you find 135 degree by 2, we get this tangent of 67.5. Therefore, we are actually rewriting this tangent of 67.5 degree equals tangent of 135 degree by 2. And now we can use the half angle identity considering x equals 135 degree. Since we are going to use this form, we write this as sine of x. Here x is 135 degree, so it is sine 135 divided by 1 plus cosine of x. So cosine of x is 135, so we replace that by 135 degree. And so we have to basically find the exact value of this expression, that is sine of 135 degree over 1 plus cosine 135 degree. Let's say this equation is number 1. Basically we have to determine the values of sine 135 degree and cosine 135 degree, and substitute into this equation. So let's see how to find both of them. The first one is sine of 135 degree. We can rewrite this as some standard angle, that is 90 degree plus 45 degree. Now this is in the form of sum angle identities. We can utilize the sum identity for sine ratio. So let's consider this as A and this as B. So we must be knowing that sine of A plus B, and this equals sine A cosine B plus cosine A sine B. This is the sum identity for sine ratio. So let's utilize this. We know that A equals 90 degree here, and B equals 45 degree here. So we are going to replace A by 90 and B by 45 degree in the expression. So therefore this will become sine 90 degree cosine 45 degree plus cosine 90 degree sine 45 degree. This is not required. Now let's utilize the standard values for sine 90, cosine 45, cosine 90 and sine 45. The standard value of sine 90 using the trigonometric table values is 1. So we replace this by 1, and cosine 45 degree is root 2 by 2. So I replace that by root 2 by 2, and the value of cosine 90 is 0 times the value of sine 45 is, once again, this is root 2 by 2. You see that this term will become 0 because we have multiply with 0, and we are left only with this product. So 1 times of root 2 by 2 equals root 2 over 2. That is, we found the value of sine of 135 degree. This equals root 2 over 2. Now in the same way, we are going to find the cosine of 135 degree. So let's write this as cosine 135 degree. We can write this as a sum of standard angles, that is 90 degree plus 45 degree. Here as well, we are going to use the sum identity for cosine ratio, that is cosine of a plus b. This equals cosine a cosine b minus sine a sine b. Here we see that a equals 90 degree, and once again b equals 45 degree. So let's write this expression by replacing a by 90 degree and b by 45 degree. So we get cosine 90 degree cosine 45 degree minus sine 90 degree sine 45 degree. And this equals the value of cosine 90 is 0 times cosine 45 is root 2 by 2 minus sine 90 is 1 multiplied with sine 45 is root 2 by 2. So again, this term is going to become 0 because we have a product with the 0 and we are left only with this term. And so this equals negative of 1 times of root 2 by 2 is negative root 2 divided by 2. And this is the value of cosine of 135 degree. Now we have obtained the values of sine 135 degree and cosine 135 degree. So this means we can substitute into the equation 1. So equation 1 basically is tangent of, we are actually finding tangent of 67.5 degree, which we have written as this we have rewritten as a tangent of 135 degree divided by 2, and this equals sine of 135 degree over 1 plus cosine of 135 degree. So this equals, now I'm going to replace sine 135 equals root 2 over 2. So therefore in the numerator I write this as root 2 divided by 2 divided by 1 plus cosine 135 degree is negative root 2 by 2. So I put negative root 2 divided by 2. And since we have plus and this one is negative, the effective term will be minus. So we are going to replace this as just 1 minus negative root 2 by 2. 1 minus negative root 2 by 2. Now let's simplify this. I write this numerator as it is. Now we have to simplify this denominator expression 1 minus root 2 by 2. So here the common denominator is 2, which means this 1 has to be multiplied with and divided by 2 and minus root 2 by 2. So this one is 2 by 2 minus root 2 by 2. Now the common denominator is 2, so we can combine the numerators, that is 2 minus root 2 divided by 2. So we have simplified this denominator to 2 minus root 2 divided by 2. Now we have a fraction in the numerator as well as in the denominator, which means we can write this as first we put the numerator term multiply with the reciprocal of the denominator term, that is 2 divided by 2 minus root 2. You see that this 2 and this 2 will become cancelled, that is they divide by itself, and so this equals root 2 divided by 2 minus root 2. Since we have a radical term in the denominator, we rationalize this. Here we rationalize this by multiplying by the conjugate of this term and also dividing by the conjugate of the term. The conjugate of this term is 2 plus root 2, and we multiply and divide by the conjugate. So I write 2 plus root 2 in the denominator as well. And so this equals, let's distribute this root 2. So this will become 2 times root 2 plus root 2 times root 2. This equals 2. Or otherwise, we can write this as square root of 2 times 2, which is 4. Square root of 4 equals 2. So this will be 2, and this divided by. Now we use the difference of squares here. That is a minus b times a plus b, and this equals a squared minus b squared. So here we can consider this 2 as a and this root 2 as b. When we use the difference of squares identity, we can put this in simple form as a squared minus b squared. So it's going to be 2 squared minus root 2 squared, that is b squared. And so this simplifies to, we can factor 2 from the numerator terms. So I write this as 2 times of root 2 plus 1. So first I write this 1 plus root 2. Can I write it in any order? And then this one is 4. 2 square is 4 minus root 2 square. This square root and this square term will get cancelled. So it's basically 2. And so this reduces to 2 times of 1 plus root 2 divided by 4 minus 2 is 2. Now we can divide this 2 in the numerator by the 2 in the denominator. So we are finally left with the term 1 plus root 2. And therefore this is the exact value of tangent of 67.5 degree.